So, like I said, tonight we are going to be discussing simulation, and within the next 2 hours or thereabouts, we should be done with all other things we want to do under risk and uncertainty. So far we have discussed expected value method. We have discussed um, standard deviation, coefficient of variation. We have discussed sensitivity analysis, which was the last thing we discussed last week. Then today, we are going to be dissecting probability. All right, sorry, simulation. So, what do you understand by simulation? Simulation represents a model that is designed principally to mimic real life situation when making business and investing decision using random variables. In the determination of expected net present value using simulation, the most important thing to do is to simulate for each variables of receipts and payments, and then use the simulated results to compute NPV. The result is what is called expected NPV using simulation. One thing you need to understand is the fact that as far as probabilistic simulation is concerned, you cannot have optimal solution. Why? Because not all the cash flows will be well represented, because we are selecting the cash flows on the basis of the random numbers given. So we are not the cash flows given in the question will not be picked. Not all of them will be picked because you are being selective. Simulation is being selective because you are picking numbers randomly. So as a result, uh, the model cannot produce optimal solution. So if that is the case, I mean, the worst case is that, of course, the simulation can only produce good enough or near optimal solution, but not optimal solution itself. All right, unlike the expected value method, whereby you consider all relevant cash flows and all of that. Okay, so that's in summary what probabilistic simulation is all about. The key thing is that whenever you want to determine expected NPV using simulation method. So the first thing you are going to do is to simulate for each variables, that is for each receipt and payment given to you. There are about 5 columns that you are expected to use whenever you want to simulate. Let me just give you the format. Okay. So whenever you want to simulate for the variable, just say simulating. Let me write that to make it clearer. Okay. Simulating for cash flow. So the cash flow of receipts and payments. So with this, there are about 5 columns you are expected to create. The first item will be the cash flow. This cash flow could be, for example, it could be savings, it could be revenue, it could be variable costs, it could be running costs or maintenance costs, whatever the cash flow has given in the question. So that will be the first item. Then thereafter, you are going to indicate the column for probability of occurrence. Then you need to find the cumulative of the probability in percentage. Then you are going to create a column for random allocation. So this random allocation is just like class interval. Okay. Then finally, you create a column for random numbers. It could be called, it can be called random number or tag number. Whatever it is the same thing. Okay, whether it is tag number or random number is the same thing. So these are the five different columns you are expected to create whenever you want to simulate. Okay, under risk and uncertainty. Okay, so that's the 5 columns. All right. Again, like I mentioned to you when we had the expected value, at all time, your probability must be equal to 1. All right. So this is the format that you are going to use whenever you want to simulate. So you can go through the material, you learn more about the concept of Monte Carlo simulation. All right, so let's have illustration. We shouldn't waste time on this. It's always very straightforward. The only thing is that it's been a while that this particular concept has been tested by the examiner. All right. So the last question that was tested was this one, illustration number 2. That was the last question tested by ICANN. So, and it's been a while. So let's go through the question together. I will read for you. The following probability estimates have been prepared for a proposed project. The company's cost of capital is 10%. You are required to calculate the expected NPV using the following tag numbers. Okay, now that's it. Then number B, explain any 4 merits of the deterministic simulation model. Now, the bottom line is that somebody will ask, how do we know that we are supposed to use simulation to determine expected NPV? So if in a question, the examiner did not mention that calculate, you should calculate expected NPV using simulation. Once you can see random number in the question, like in this case now, these are the random numbers given. Okay, so once you can see random number in the question, you need nobody to tell you that you are supposed to use simulation because every method has its own unique way of determining expected value or of incorporating risk into an investment proposal. So whenever you see random number or what is called tag number, then you should know that you are expected to use simulation. That's the only unique way of simulation because it's only simulation that make use of random number, okay? So every other techniques, they don't make use of random number. So if you can see random number in a question or it is called tag number, you should know that you are supposed to use simulation. So in this question, examiner wants us to determine expected NPV. So examiner did not tell you to use simulation, but it is implied because you have been given random number. So in this case, what are we supposed to do to solve this question? The first thing you need to do is to simulate for each variables. What are the variables? The variables in this question include revenue as well as running costs. Those are the uh, variables of receipt and payments given in the question. So you are going to simulate for revenue separately. You simulate for running costs separately. Then step 2, you use the simulated results to go and compute NPV for each set. The NPV in this question, you are given 3 different sets. So that means you are going to compute three different NPV because you are going to be pairing for each set. You are going to pair revenue with running costs for set 1, revenue with running costs for set 2, do the same thing for set 3. Then at the end of the day, you find the average expected value computed. So that is what you are supposed to do. I will stop sharing this and move to the working notes so that quickly we can complete this within the next few minutes. Okay. So company. So we are not given the name of the company, so let's move on. So like I said, the first thing you are going to do is to simulate. Therefore, I would then say simulating. Before then, solution to illustration. Solution to illustration number 2. Okay. Then simulating for revenue. We do it variable by variable. So the first item here will be the revenue. Then probability, cumulative, or probability in percentage, random, allocation, then random number. In this case, examiner did not call it random number. We are given tag number. So you have to call it tag number, whatever the examiner has called it. Don't say because they are the same. You now use random number. Be consistent. So examiner has called it tag number. We then go back to the question. Call the revenue for me. What are the amount of revenue? The first one is 800,000. What's the next one?
1 million.
1 million. Next.
1.1.
1,100,000.
1.2.
1.2 million. So those are the revenue given. Give me the probability.
0.15.
0.15.
0.40.
Okay.
0.25.
And then
0.2. 0.20.
0.20. So 0.2, that's 0.45. Okay, that's 1. Remember what I said. At all time, your probability must be equal to 1.
1.
Okay, so we need to find the cumulative of the probability in percentage. The first probability is 15. 15 plus 40 is 55. 55 plus 25 is 80. 80 plus 20 is 100. That's the cumulative of the probability. The next thing we want to do is to determine the random allocation. Like I mentioned, random allocation is just like class interval. So we are starting from 0, 0. So you are using the cumulative of the probability to form the random allocation. So the first letter, the first figure in the probability is 15. 1 minus 15 is 14. After 14 is 15. 1 minus 55 is 54. After 54 is 55. 1 minus 80 is 79. After 79 is 80 to 99. So now that we have determined our random allocation, then we need to find the tag number. The tag number will be given to you in the question. All you need to do is to assign the tag number. Okay, you assign the tag number using the random allocation. I will then go to the question. What are the tag numbers given to us for revenue? The first tag number is 35. Okay, so I will now look at the random allocation. Where does tag number 35, where does the 35 lies? So 35 is between 15 and 54. Therefore, I would then say 35. I'll pick the next tag number, which is 22. Again, 22 lies between 15 and 54. Here will be 22. Next one is 68. 68 is between 55 and 79. Here is 68. So with this, I have simulated for revenue. This is how to simulate for any variable. Now that I'm done with revenue, I will also simulate for running costs. Simulating for running costs. Okay. All right. So the first item will be the running costs. Followed by probability, then cumulative of probability in percentage, random, allocation, then tag number. Okay. Then give me the running costs. Kunle, are you there?
500,000.
500,000,
600,000.
600,
700,000.
700. Is that all?
Yes.
Okay, then give me the probability.
0.4.
Okay,
0.2.
and then
0.4.
remember what I said. At all time, the probability must be equal to 1. So we need to find the cumulative of the probability. The first probability is 40. 40 plus 20 is 60. 60 plus 40 is 100. Then random allocation. So like I said, random allocation is just like class interval. So we are starting from 0, 0. Okay? So 1 minus 40 will give us 39, starting from the first letter, first the figure in the probability. After 39 is 40. 1 minus 60 is 59. After 59 is 60. 1 minus 100 is 99. So that's the random allocation. I will then go to the question from the tag number given to me for running costs. The first tag number is 70. I will now look at the random allocation. Where does 70 lie? 70 is between 60 to 99. So here will be 70. The next tag number is 52. 52 lies in the second row, in the second one, which is here is 52. Between 40 and 59, that's 52. Then the last one is 90. 90 lies between 60 and 99. Again, with this, I've simulated for running costs. I just finished the first step. The second step to calculating expected NPV using simulation method is what I just completed. The second step we want to do now is to compute NPV using the simulated results. Okay, so I would then say calculating expected net present value using simulation. Okay. Therefore, when you want to compute your NPV, like I mentioned during my explanation, when you want to compute your NPV, you are going to be doing that set by set. You are going to pair revenue with running costs on the basis of the set number given to you. So for set 1, here, item, cash flow, discount factor at 10%, then present value. Year 0. Initial outlay of the project is how much? 800,000. Okay. 800,000. Year one, I will go to the question, what's the useful life? We are told useful life is 5 years. So year 1 to 5. Revenue. Then year 1 to 5, running costs. So I will then go back to my calculation. Before I go back to my initial workings, I need to find out what's the first, for set 1, what's the tag number for revenue and running costs? For set 1, tag number for revenue is 35. Watch out. I will then go to the simulation under revenue. The simulation we have done for revenue. Where do we have 35? 35 is somewhere here. This is where we indicated 35 tag number. Therefore, you trace it to the left where you have the revenue. The revenue is 1 million. So I will then go there and put 1 million here. Again, for set 1, running costs, tag number is 70. So I will then look at I will go back to my simulation for running costs. Where do I have 70? 70 is here. We indicated 70 there, tag number. Trace it to the left where you have the running costs. It is 700,000 naira. So I will then indicate 700,000. So I need to calculate annuity factor of year 1 to 5 at 10%. So
3.791.
3.791, 3.791. So this will give us 3,791,000. Then what about the running costs? Yeah.
2,653,700.
2,653,700. Did you say
700.
700? Okay. So final answer. This will give us 337. Is it 337, 700 or whatever? Please confirm. 337,
337,300.
300. So that's it. That's our NPV for the first set. I will do for second set, set 2. Repeat the same thing. Yeah. Description of items, cash flow, discount factor at 10%. Then the present value, year 0, 1 to 5, then 1 to 5. Initial outlay, revenue, then running cost. 800,000 initial outlay. Now for set 2, I will go back to the revenue. Before that, from the question for set 2, tag number for revenue is 22. So I will then go to my simulation for revenue. Where do I have 22? 22 tag number lies on the same revenue of 1 million naira. Okay, here is 1 million. Then for running costs, set 2 is 52. Tag number 52. Okay, this is tag number 52. Then trace it to the left. That's 600,000 naira. Okay, 600,000. So multiply by 1, 800, 3.791. Then multiply. What do you have there?
3,791,000.
Take it again.
3,791,000.
I mean,
No, I mean that's the second one, 2,274,600.
2,274,600. 674.
274, 274.
2,274,000.
Yes, sir. 600. 600.
600 or 800.
600.
Okay. So what's the final answer? Seven one six
716, 400.
400. Okay. So I would then do for set 3. If you have 10 sets, if you are given 10 sets, that means you are going to calculate 10 different MPV. Set 3. Repeat the same thing. Discount factor at 10%. Initial outlay is 800,000. Multiply by 1. 800,000. Then revenue. Running cost. So for set 3, tag number is 68 for revenue. So 68. Here is 68. Trace it to the left, that's 1.1 million. 1.1 million multiplied by 3.791. Then running costs. Tag number for running costs is 90. So 90 lies on the last running cost of 700,000. 700,000 multiplied by 3.791. Give me the present value, please. Yes. What's the PV?
716,400.
716. I said the PV present value.
Oh, for the revenue, 4,170,100.
4,170,400. So the difference
100.
100. So this will then give you 716
716,400.
400. Okay then. So now that we have the MPV for all the sets, all you can't have 3 different MPVs. It has to be only one number, but you have 3. So all you need to do is to just find the average expected MPV. Therefore, I would then say average expected net present value would then be equal to, the first one is 337, is it 400? 300, 337, 300 plus 716, 400 plus 716, 400. Because we added 3 different numbers together, you have to divide it by 3. So this will give us 595,003. Please confirm.
590,003.
590, okay? So that's it. Therefore, I can then say the expected
Sir, is 590,033.
033. Oh, okay. 033. So the expected MPV is 590,033 naira. So that's end of the question. That's end of the question. It's as simple as that. The most important thing is for you to know how to simulate. Once you know how to simulate, every other one is straightforward. And the one thing about this, about simulation, is that you are picking the numbers randomly based on the set number, or based on the random number given to you or tag number given to you. So it's not something that is direct. So you must know the techniques for you to be able to determine your expected value. All right, so that's end of simulation. So you can go back to the ebook. You will see additional illustrations there. But we don't have the luxury of time now because we are behind. So we need to move on. Okay. All right then. So let me know if you have any question on this so that we can move to the next one. Okay, so let's go to decision tree. Let's go to decision tree. I'll stop sharing this. Let's talk about decision tree. Okay, what do you understand by decision tree? The decision tree is a pictorial representation of various courses of action involving a complex situation in making, investing, and business decisions. Businesses generally involved in merger and acquisition transaction, make or buy decision, international contraction, divestments, okay, expansion, and all of that. All these activities require meticulous efforts for the company to be able to maximize value, okay, to be able to maximize value for the owners of the business. Therefore, the selection of appropriate course of action will depend on the expected value or the expected NBV that will be computed at the end of the day. Now, as far as decision tree is concerned, there are basically two types of nodes, okay? We have decision node, we also have event node. The decision node will be drawn each time you want to calculate expected value, you want to determine the expected value or expected NPV. So you are going to need decision node. Everything starts and ends with the decision node. When you want to construct your tree diagram, the first thing you are going to do is to draw the decision node. You have to draw this decision node. Now, the direction of your decision node will depend on the alternative courses of actions available. Say, for example, you have 3 courses of action. Out of these 3 alternatives, you need to make a decision. You need to select one. In that case, the arrow that we follow will be 3 because you have 3 choices. You have 3 alternative courses of action. But if you have only 2, this is how you are going to do it. If you have only 1 course of action, okay, only 1 course of action, then only 1 directional arrow will follow. So anytime you want to you want to construct your tree diagram, you must start from the decision node. You work forward, incorporating all the scenarios as printed, including the probability, the state of nature, and all of that. Then when you now want to make a decision, you walk backward to the starting point, which is the decision node. So this second one, which is the chance node or event node, will be used whenever you have state of nature, where you have the probability of occurrence. Okay, whenever you want to indicate probability of occurrence or state of nature, that's when you use the chance node to represent that or to construct your tree diagram. That's that. But that notwithstanding, Your decision node does not mean that it will start from the from the origin and also end at that same point. In between your tree diagram, you may also have a course of action to take. So as a result, you will need to draw the tree diagram as well. So it is not compulsory that the decision node must be from the beginning of your tree diagram. It can occur anywhere. What is important is that whenever you want to make a decision, okay, whenever you want to make a selection between various alternatives available, then you need to indicate the decision node. All right. So what are the basic steps that you need to carry out whenever you want to construct your tree diagram, or you want to determine expected value or expected NPV? The first thing you need to do is to construct a payoff table. The payoff table represents a table that shows the decision variables, which is represented horizontally, and then the state of nature represented vertically. Okay, so that decision node is what you are going to use. Sorry, the payoff table is what you are going to use to construct your tree diagram. But at times you may just ignore the payoff table and just go straight if you know what you are doing. So that's step one. Step one is to construct a payoff table. Then step two, construct a tree diagram. Okay, you construct a tree diagram. Then step three, you assign probability of occurrence to each state of nature. That's step three. Then step four, you label your tree diagram alphabetically or numerically. You can use letter to label it. You can use figure to label your node, all the nodes, both decision and then the event node. You label them. Then step five is to advise. Okay, you advise or you select the alternative course of action. All right, so that's what you need to do as far as decision tree is concerned. Okay, so at this point, now, how will you know you are supposed to use decision tree? How do you know whether you are supposed to use decision tree or not? Like I mentioned, if the investments involve a complex situation, okay, whenever you want to make business and investing decision that involve a complex situation, then in that case, expected value may not be sufficient for you to be able to do that, especially when you have sub decision to make. All right. Once you notice that the way the question is being structured, the way the scenario is being painted is different from what you are familiar with under expected value, under standard deviation, under the simulation, then you should know that this is you are supposed to use the decision tree. All right. Okay. So that's that. At this point, let's have illustration. Okay. Let's see. Okay, that's it. Let's have this illustration 7. I think this decision tree, and it's been a while also. Okay, so I need somebody to read for us, please. Who will help us to read? Yeah.
All right, so I'm reading.
Thank you.
Yeah,
Kunle.
Michelin Limited has a new wonder product of which it expects great things. At the moment, the company has 2 courses of action open to it to test market the product or abandon it. If the company test markets it, the cost will be 100,000 naira and the market response will be positive or negative with probabilities of 0.60 and 0.40 respectively. If the response is positive, the company could either abandon the product or market it full scale. If it markets the product full scale, the outcome might be low, medium, or high demand, and the respective net gain stroke losses would be negative 200, 200, or 1,000 in units of 1,000 naira. The result could range from a net loss of 200,000 to a gain of 1 million. These outcomes have probabilities of 0.20, 0.50, and 0.30 respectively. If the result of the test marketing is negative and the company goes ahead and market the product, estimated losses would be 600,000. If at any point the company abandons the product, there would be a net gain of 50,000 from the sales of the scrap. All the financial values have been discounted to the present value. You are required to A, draw a decision tree to illustrate the above scenario, B, advise the company on the option to be selected.
Thank you very much, Kunle. Yes, that is the question. Examiner is asking you to draw a decision tree to illustrate the above scenario. Even without the examiner telling you to draw a decision tree, you should know that you are going to use decision tree to analyze this scenario, because you cannot use expected value for this. You can also not use a standard deviation. There's no simulation, because in this question, you are not given tag number. Therefore, you cannot use a simulation. So the best method to use to analyze this situation is decision tree. Okay? Now, you are asked to determine, you are asked to advise the company on the option to be selected. So the major work, in fact, even the one the examiner is asking you to advise, which carries higher marks, that the decision tree is a major thing to do, because once your decision tree is correct, then whatever you are going to do thereafter will also be correct. If you assign the value and the probability appropriately. But without wasting more time, let me just stop sharing this and move straight to the working notes so that I can show you. Okay. The name of the company is Michelin. That's illustration 7. Solution to illustration 7. Michelin Limited. So whether examiner asks you or not, the first thing you are going to do is to construct a tree diagram. Number A, constructing a tree diagram. Okay, now pay attention, please. Whenever you want to construct a tree diagram, say on the day of your exam, please, you have to do a rough sketch at the back of your answer booklets, because there is no how you are going to have a perfect drawing on the first instance. There will be mistakes here and there. And for you to have a clean drawing, you need to first of all go and make a rough sketch at the back of your answer booklet. Don't do it on your question paper. If you do it on your question paper, the invigilator may think that you want to write expo to a colleague or to a friend. Therefore, and if you are caught, you may be penalized. So avoid that. Don't write anything on your question paper. It's an instruction. So what are you supposed to do? Like I said, just go ahead and make a rough sketch at the back of your answer booklet. Once you are satisfied with your drawing, then you can now transfer it to the main page of your answer booklet where you want it to be. That's one. Then number 2, when you are drawing your tree diagram, please make it very bold. Make it very bold and use a pencil. Don't use pen, but use pencil to do your drawing, because once you make mistake, you can easily use a cleaner or eraser to clean it up. But if you have used pen, there's no way you'll be able to clean it again. So you have to cancel and start from another page. And how many canceling are you going to do? So please. So don't forget what I said. You have to make your tree diagram very big and bold. Don't be a mindset the way you normally do in the class, that you'll be dividing one page into 4. You know, try to manage your notes. Don't do that on the day of your exam. If you finish your answer booklet, request for more. The invigilator will give it to you. Okay? So that's that. Now, to start with, whenever you want to construct your tree diagram, we said always start from the left, from the origin. Always start from the left with your decision node. So I would then okay, let me see. All right. Hopefully, I will have a perfect drawing. All right. What I did, I will then go back to the question. Let's follow the scenario together. Remember what I told you. The direction of the arrows of your decision node will depend on the alternative courses of action available. Okay. So in this particular question, we are told that Michelin Limited has a new wonder product of which it expects great things. At the moment, the company has 2 courses of action. That means there are 2 alternatives available. One is to test market the product, then 2 is to abandon it. Therefore, I would then say test markets, abandon. Okay, so test, I write it there. Test markets. Then abandon. Okay, those are the 2 courses of action available. Immediately after your decision node, you need to indicate the chance node to complete that particular scenario. To complete the scenario, you draw a cycle as your event node. Okay. All right. Now, after this, I need to go back to the question and check the scenario, continue from reading the scenario. You're now told that if the company test markets it, the cost will be 100,000 naira and the market response could be positive or negative with probability of 0.6 and 0.4. Okay. So if the company test market the product, the cost could be 100,000 naira. That's the amount they will spend. Let me rewrite that. 100,000. Okay. It's a cost, so you can put it in brackets. Let me rewrite it because of this. This one is choking. Let me extend it. Okay. Better. So all right, so 100,000. That's it. So you're now told that if the company test market the products, the response will be positive or negative. Positive or negative is a state of nature. That's the events. So I will then come here. In that case, from the under test markets, I have positive response. I also have negative response. Okay, so here is positive, then negative. Okay, then I will read further. with a probability of 0.6 and 0.4. Probability of 0.6, then 0.4. Kunle and Co. Hope you are following.
Yeah, we
Yes,
just
sir.
Okay, then. So move to the second paragraph. If the response is positive, the company could either abandon the product or market it full scale. So if the response is positive, here is positive, the response, the company could either market full scale or abandon it. That's a decision to be made. We are told that if the response is positive, the company could either market it full scale or abandon it. So you want to make a decision on whether you should abandon or you should market full scale. Therefore, you are supposed to indicate, you are supposed to draw a decision node. Okay. Let me see if I can extend this beyond that. Let me redraw this. Okay. Do the same thing for this. You see the way I'm drawing and cleaning it again? That's the way you are going to experience it when you are doing it on your own. You can't have a perfect drawing at the first instance. There will be room for correction. Okay, so we want to make a decision as to whether to abandon or market full scale. Therefore, you need to draw a decision node. All right. Okay. So that's a decision node. So you want to know whether you should market. See what I'm talking about now. It's going up. Then abandon. So we are told whether we should abandon, then market full scale. Market full scale. Okay. Go back to the question. If it markets the product full scale, the outcome might be low, medium, or high. So there are three courses of action available. There are three states of nature. So if you market the product full scale, you need to draw a chance node. So if you market the product full scale, the response could be, the outcome might be low, medium, then high. So low, medium, then high. See? So I will then come here. This one is low, medium, then high. Let me rewrite that. Okay. Again. And the respective net gains or losses will be 200 negative, 200 positive, then 1,000 positive in units of 1,000 naira. So which is 200,000 naira loss, 200,000 naira gain, and then 1 million naira gain. All right, so let's go and indicate the value. So here is 200,000 naira loss if it is low. Then let me draw this one. Okay. For the medium, let me change the direction. There is the medium. You see the way I'm struggling with my drawing. So here is also 200,000 naira gain positive. Then here is 1 million naira gain. All right. So what else? These outcomes have probabilities of 0.2, 0.5, and then 0.3. Okay. So there's a probability of 0.2, 0.3, 0.5, and a 0.3. Okay. What else? We are moving to the fourth paragraph. If the result of the test marketing is negative, okay, the result of test marketing, here is the test marketing is negative. This is where you have the negative. This is where we have the negative. So if the result of the test market is negative, you are told that, and the company goes ahead and market the products, estimated losses will be 600,000. Again, there's a decision there under the test markets. So you can either test market the products, you are told that if the result is test marketing is negative and the company goes ahead and market it, so you have decision as to whether to market the product full scale or you abandon it under negative as well. So let's indicate that first. Okay. All right. So we are told that if the company test market the products, if the test marketing is negative, the company can either market full scale or abandon. So you indicate your arrow. You indicate your arrow. This is test market. This is market full scale. Market full scale under negative, then abandon. Okay. What else? We are now told that, yes, the estimated losses will be 600,000. So here the estimated losses will be 600,000. That is, if you market full scale under negative, losses of 600,000. All right. So what else? At any point, the company abandons the products, there will be a net gain of 50,000 naira from the sale of the scrap. All the financial values have been discounted to the present value. So anywhere you see abandon, you are supposed to give 50,000 naira gain. Therefore, here is abandon. The first abandonment is this one, where we have the decision node. All right, the starting point. Let me redraw this, push this one down a little bit. Okay. Therefore, yeah. So here will be 50. If I like, I need to close. Now we have represented all the scenarios. So I need to close the diagram. I need to close the tree with an event node. Okay. All right. All right. Then this one, if I like, I can push it to the front. Okay. This one too, I can push it to the front to make it align properly. Okay. Then this one too. All right. So if I like, even this one, I can push it to the front. I can push it to the front to make it align with them. I'm not an artist. I've tried. Yes. Okay then. So we're now told that at every point you is abandoned, then you should give 50,000 naira net gain. So there's an abandon here. Here is also abandon. There's also abandon. Then we give 50,000. So that's that. So we have indicated the probability of occurrence as well as the state of nature. We have attached value to each one. So the next thing we need to do now is to label our nodes alphabetically or numerically. So we are going to use alphabet. So say this is A, this is B. Let me make this B bolder. Okay. This is B. Make this one too bigger. All right. This is C. This is D. This is E. E, F. Okay. G. H. I. J. K. L. Okay. Let me give him space. Okay. Yeah, that's it. I'm done. I'm done with the diagram. I'm done with the diagram. So the next thing I need to do now is to find expected value for each node. We need to calculate value for each node. For node A will be equal to, we need to calculate expected value for node A. Node A, we have 200,000 losses multiplied by a probability of 0.2. Okay? So A will be 200,000 multiplied by 0.2, which is equal to 40,000 naira loss. For node B, we have 200,000 naira profits multiplied by 50% of probability. So 200,000 naira multiplied by 0.5, which is equal to 100,000. Then node C, 1 million naira multiplied by 0.3, which is equal to 300,000. So when you add it up, that will produce 360,000. So this 360,000 will be for node H. You will see that node H is coming from node A, B, and C. Therefore, I can then say node H. We already have value for node D, which is 50,000. Node E is 600,000. Node F is 50,000. Node G is 50,000. So we already have value for all of that. But we don't have value for H, I, then J, K, L. Those are the ones we need to calculate for now. I will then say node H. Node H. Under node H, you see that node H is coming from node A, B, and C. Therefore, combine the expected value of nodes A, B, and C, which is 360,000 naira, as shown above. Okay, so for node H, I would then come in and put 360,000. Hope this one will occupy, will be sufficient. Okay, that's it. That's the 360,000 naira, which is the product of A, B, and C. You know, this one is minus 40,000. Here is 100,000. Then here is 300,000. So by the time you add up the three of them, that's what make up the 360. The next item we want to talk about is node I. Node I. You will notice that node I is coming from node H and node D. Node I is coming from node H and node D. Okay? So in that, we need to make, there's a decision to be made in node I. The decision is between whether to market the products full scale or abandon it. If the company market the product full scale, that's an expected gain is 360,000 naira. But if the company abandon the products, the net gain is 50,000. That means the company should market full scale. 360 is more than that. So I would then say the choice. The choice is between whether to market the products full scale or abandon. If the company markets, if the company market the products full scale, the expected value will be 360,000 naira. But if the product is abandoned, the net gain will be 50,000 naira. Therefore, the company should market the product full scale, or the products should be marketed full scale. That's it. So 360. I will then come here and put 360 here. Okay. So that's that. Then for node J, the choice is between whether to market full scale or abandon. If the company market full scale, there's a net loss of 600,000. If the product is abandoned, there's a net gain of 50,000. Therefore, the company should abandon the product under negative. So that's node J. So I would then say node J. The choice is between whether to market the products or abandon it. Marketing the products will generate a loss of 600,000 naira. Why abandoning will result in a net gain of 50,000 naira. Under this circumstance, the product should be abandoned. Okay. That's it. So I will then go there and put 50,000 in the cell. Here will be 50,000. Now, we are moving to node K. Node K, we are not making a decision. So there's a probability of positive and negative. All you need to do is to find the expected value for node K. So I would then say node K. Let me rewrite that, make it bold. For node K, combine the expected value of nodes. What are the names of the nodes? Node I and J. Combine the expected value of node I and J as shown below. So node, then working, then expected value. Node I, node J. Node I, the expected value of node I is 360 under positive. The expected value of positive is 360 at a probability of 0.6. The expected value of node J is 50,000 at a probability of 0.4. So here will be 360,000 multiplied by probability of 0.6. Here is 50,000 with a probability of 0.4. So let's multiply. So 360,000 multiplied by 0.6.
216,000.
216,000. Here is 216,000. Then here will be
20,000.
20,000. So when you add it up, that will give us 236,000. So that's the expected value that will go to node K. So here is 236,000. Now, there's a choice to be made between node K and node G under for L. L is the final node. Node L is the final node. That's where you have the final decision to be made. So, and the choice is between node K and G. That is whether to test market the product or abandon it. So if the company test market the products, there is an expected gain of 236,000, but the company will incur 100,000 naira. So 236 minus 100,000 will give us 136,000. If the company abandon the products, the net gain is 50,000. Since 136,000 is more than 50,000, then the company should test market the product. That's the final decision. So I will then go down there and put in the information. Node L. Okay. The choice is between node K and G. Let me confirm. Yes, node K and G. The choice is between nodes K and G. That is whether to test markets or abandon the product. Okay. If the company test markets the products, okay, the expected gain will be 136,000 naira. That is 236,000 minus 100,000 naira cost that will be incurred. Okay. Whereas if the product is abandoned, the net gain will be 50,000 naira. Therefore, hence, the company should test markets the products. Okay, the company should test market the products. So I will then come there and put 136,000 naira. 136,000 naira. That's the end of the question. You can see. That's how to draw a tree diagram. So let me know if you have any question on this, so that we can move to
Yes, sir.
decision. Yes, talk to me.
So if we have to do this under exam condition and we have to like first do a rough sketch at the back of our answer sheet before
Yes.
transferring it to the main question to the main answer sheet, the whole time will be
Yeah.
spent.
You say what? What time will be?
I said you advised that we should first do a sketch at the back of our answer sheet.
Yes.
And from all indication, this could take about 30 minutes just sketching. And then thereafter transfer it to the main answer paper.
How do you mean it
Now,
will take you 30 minutes to sketch? All this thing I've been doing since have I spent you up to 30 minutes?
and that's because we have mastered it, sir.
And it's because it took more time because of the fact that this is online. I didn't mean it was to be a physical class. It is easier for me. You know, this is stressful for me to draw on my PC screen, you know. But in any case, yes, you know, you never can tell, you don't know what you are going to meet on that day. And then that's why you don't ignore any topic when you are preparing for an exam. No matter how simple is that topic, you don't ignore, you have to give adequate attention to each of them, because you never can tell. It may be the one you are even ignoring, or the one you know the most. Okay, is what God forbid, of all the 7 questions that you are going to be given on that day, it may well be that that's the only one you know very well, that you are very sure of. What are you going to do in that case? You are going to devote your time to ensure that you earn the full mark now, isn't it? So the bottom line is that, yes, it takes time. Really, I can't even have, like I usually tell my students that, please, on the day of your exam, when you see question under decision tree, don't make it your first attempt, except in the worst case scenario. That's only one you know very well. So that's the only option. Other than that, it takes time. It takes time, because you have to think outside the box, analyze the scenario, find a way of ensuring that you draw your tree appropriately. Then you now begin to determine the expected value. Is a whole lot. It takes time. It takes time to complete. All right. But in any case, it's what it is. All right.
One more question. Who came up
Yeah.
with the idea of this decision tree? Just like this probabilistic simulation is Monte Carlo. Who
Just
came up with the idea?
as you have propaganda, or as you have people, theories that formulated a particular concept. The same thing on this one too. Just like you have in the simulation, most of all those things are named after the name of the event or whatever. But in any case, it's what it is. We are less concerned with whoever that have developed it. The bottom line is that it's a concept that you have to follow. It's a concept that you have to follow in this particular subject. So it's what it is. Yeah.
Thank you,
Okay.
sir.
You are welcome. Yes. Any other questions so that we can move to the final scope? Yes. Okay. So let's move to decision analysis. Okay. Let me stop sharing this. And then in solving for the decision analysis, because we have just about 1 hour more. So let me see, let me use my, let me use the ebook to explain this, so that we spend about 20 minutes for the explanation of the concepts, then we spend the remaining minutes for calculations. All right. So let's see. Yeah. Okay. Yes, let's use this material to explain decision analysis. Now, what do you understand by decision analysis? Okay, let me. So, decision analysis represents a systematic, quantitative, and visual approach to making strategic business decisions by identifying and evaluating available courses of action and the selection of an alternative that produces the most favorable outcome. However, the decision outcome that arises from the same available information may vary from one individual investor to another because of their level of perceived risk. We are different individuals with different risk appetites. An individual that wants a higher return must be willing and ready to accept a higher risk, and vice versa. And that is why that any decision outcome that will arise from a particular available information will always vary from one decision maker to another relative to their risk appetites. Now, I will not bother you with the story as far as decision analysis is concerned, so you can read them through, all right? The focus is that we want to talk about the methods of determining expected value under decision analysis. So you can read about the uses of decision analysis. Part of it is what we want to do in investments project evaluation. Then you can read about the limitation. The limitation of decision analysis is very straightforward, okay? Which has to do with analysis paralysis. You know, when you have so much alternative courses of action, you wouldn't know which one to select again. For example, when you want to buy something, maybe you want to buy a cloth, then you now went to clothing shop. You are given variety of clothes, different kinds of clothes. Then you get confused because you don't know, all of them are beautiful. You don't know which one to select. At that point, you started calling people, please, how do you see this dress? Is it okay? Are you sure? Okay, I will buy it. So you are already confused because you have so many options available. So that is what is called analysis paralysis. When you have too much available information and you are unable to make timely decision or no decision, then that means you are suffering from analysis paralysis. All right. So that's the major limitation for under decision analysis. Now, where we have major work is on how to, I need to explain to you what you need to do under each decision scenario or under decision criteria or method. Before we go into the, I've already explained to you earlier today on the payoff table. I told you that the payoff table is a table that is constructed with the variable, with the decision variable represented horizontally, while the state of nature is represented vertically. All right. So whenever you want to construct a payoff table, especially under this decision analysis, at all time you must construct your payoff table. You have to. So on the vertical axis, is where you have your decision variable. Your decision variable is the available alternative where you want to make a choice. Say, for example, you want to make a choice between whether to invest in product A or product B or product C. So you want to make a choice. That is where you have the alternative courses of action. That's where the alternative lies. Then, sorry, oh no, my pen is not connecting. Okay, it's back. Now, whenever you have a choice to make, so in that case, horizontally, you have to represent the decision horizontally. Then the state of nature must be represented vertically. Like I said, the state of nature is the events in the economy. You can have high, medium, low. You can have success, failure. You can have optimistic, most likely, pessimistic. You can have above, average, below. You can have good, bad, worse. Anything, whatever you have as the state of nature must be represented vertically in your payoff table. All right. So, like I said, the payoff table must be constructed before using any of the method of evaluation. Whenever you want to evaluate, you have to first construct the payoff table. Now, that is for payoff table. The next thing we want to talk about is methods of evaluation under decision analysis. What are the methods of evaluation? There are 4 key methods. There are 5 of them, but the focus of this class will be on 4. The first method of evaluation is Maximus. Maximus criterion. We have Maximi criterion. We also have minimus or salvage regrets criterion. We have Laplace-Bayes theorem, or simply put, Laplace criterion. So let us explain each of them one by one. I will not bother you with too much grammar or with too much notes. I just want to tell you what you need to do. As far as Maximus criterion is concerned, under Maximus, it is mostly preferred. Maximus criterion is mostly preferred by an optimistic decision maker. And the decision maker expects the best of occurrence. Okay, the decision maker expects the best to occur. So in that case, under Maximus criterion, what are you supposed to do? The first thing you are going to do is that at each, for the payoff table that you have constructed, this payoff table that you have constructed, okay, let me use this. For this payoff table that you have constructed, using Maximus criterion, okay, using Maximus, the first thing you are going to do, the first step, is to select the highest, the maximum expected value in each of the rows. For example, for alternative A, between good and bad, whichever one that is the highest, you select it. Between alternative B, whichever one that is the highest or the higher one, you select it. Between alternative C, select the highest number. Once you have, in the first instance, you have selected the highest value. Then to now make a decision, you need to select the maximum of the maximum value. That is what you need to do under Maximus. That's why it is called Maximus. You start from the maximum value of each row. Then you now select the maximum of the maximum value you have initially picked. So that is what you need to do under Maximus. So I've already given you the note here, so you can just go through it. I've already explained that. Then let's talk about Maximi. Under Maximi criterion is a decision criterion that is used or that is mostly preferred by a pessimistic individual investor. The decision maker expects the worst to occur. Under Maximi, the most important thing to do is to select the minimum number or the minimum payoff value in each row. And then to make a decision, you select the worst, or you select the maximum of the worst occurrence. That's what you need to do under Maximi criterion. Remember what I said, because examiner can ask you to explain what you mean by maximum and all of that. So just note that the maximum criterion is used by a pessimistic decision maker, whereby the decision maker or the investor or the manager expects the worst to occur. Okay, so to do this, in order to make a decision, the decision maker will need to select the worst possible outcome, and then select the highest of the worst possible outcome. So that is what you need to do. So just follow. I've already explained each and every one of them. You know what to do now. Then the third one is minimax. Minimax. Minimax has about 5 procedures, or I can crash it to 4 procedures that you need to carry out. However, when you talk about minimax, it's also known as salvage regrets, okay? Salvage regret criterion due to opportunity loss through bad decision being made, all right? So it's a criterion that minimizes the maximum regrets. So the approach is mostly useful for a risk-neutral decision maker or a sore loser who wishes to avoid any wrong decision being made, all right? As far as minimax is concerned, when you want to evaluate an alternative using minimax or salvage regret criterion, there are 4 key procedures you are supposed to follow. From the payoff table, from this payoff table, when you want to use, okay, when you want to use salvage regrets to evaluate an alternative, the first step you are going to do is to identify the highest figure, the highest value in each column. You identify the highest value in each column, and then you deduct the highest value from itself and from the other value in each of the columns. All right. Say, for example, in this under good, we have under good, say we have 1,000 for A, 500 for B, then 200 for C. As you can see, 1,000 is higher than the rest figures. Therefore, step 1 says identify the highest figure in each column and deduct the figure from itself and from other figures in the column. Therefore, I will then say 1,000 minus 1,000. That will give me 0. 1,000 minus 500 will give me 500. 1,000 minus 200 will give me 800. So I will have the revised payoff value. Then, of course, I will do the same thing under bad. Whatever figure I've been given under bad, I will find the highest figure, then I will deduct it from itself and then other figures in the column. So that's all you are going to do in step 1. Then step 2, you construct a new payoff table, which is known as a salvage regress table. Okay, you construct a new table known as a salvage regret table. So all the results that you have in step 1 is what you are going to put in the new payoff table. Then step 3, you select the maximum payoff value in each row, and then you select the minimum of the maximum value for your decision. That's what you need to do under minimax. That's what you need to do under minimax. But I have 5, I've converted it to 4 procedures. The first procedure says here that you should identify the highest value from the alternative in each of the columns, okay, from the original payoff table. Subtract the highest figure from other values and itself in each column. Then step 3, construct a new payoff table called regret matrix table. Choose the maximum value in each row. Select the minimum value under, select the minimum value. Okay. Yeah, that's it. That's what you need to do under minimax. Then the last one is Laplace rule. All right, under Laplace is also known as the principle of insufficiency. It's also known as the principle of insufficiency. The principle states that equal probability should be assigned to each state of nature, especially where the probability of occurrence is not available. Okay, when you are not given the probability of occurrence, then you are expected to assign probability to each possible outcomes. The probability that you are going to assign, which is probability of 1 over 3, okay, sorry, 1 over n, the probability of 1 over n. The n is the state of nature. So the n will vary depending on the state of nature. If, for example, you have 3 states of nature, that will be 1 over n. If you have 4 different states of nature, that will be 1 over 4. If you have 2 states of nature, that will be 1 over 2 probability that you are going to assign. Okay? Say, for example, you have state of nature A, B, and C. Okay? Then, of course, you have alternative courses of action. Say, for example, you have M and N. You want to choose whether to invest in M or in N. Say, for example, A has 300 for M, 200, then 500. N has 400, 100, then 200. So using Laplace rule, what you are supposed to do is to assign probability to each state of nature. State of nature is represented vertically. That's A, B, and C. Therefore, what am I supposed to do for M? I would then say equal to the payoff value for A for M under A is 300. I will say 300 multiplied by, what are the states of nature? I have 3 states of nature, A, B, and C. Therefore, multiply by 1 over 3 plus, I'll pick the second one under the second state of nature, which is 200 multiplied by 1 over 3 plus the third state of nature, 500 multiplied by 1 over 3. Then I will get my answer. I will add everything together. That will be the answer. So that's what you need to do under Laplace rule. Then I will do for M, I will also do for N. So at the end of the day, any alternative with the highest expected value is the one that will be selected. Okay? So that's what you need to do under Laplace rule. Okay? It's as simple as that. So at this point, let's have an illustration. So let's have illustration. Let's start with this illustration number 1. Then we solve the one that it was tested in May 2023. That is compulsory question number 1B. Okay. So yeah, I need somebody to read illustration number 1 for us. Can imagine half of the class is attending class today. No worries. So somebody should read for us, please.
Which illustration, sir?
Illustration 1. The one you have on the screen.
Okay. Zebrato Limited is planning to invest in 3 mutually exclusive products, A, B, and C, and has consulted you as a business advisor on the best alternative course of action. The available information shows that the company will earn 8 million naira
Yes.
returns during the booming period on product A, while 2 million naira loss will be incurred on product B, and a 16 million naira returns will be achieved on product C. When the economy is steady, 1 million naira profit will be achieved on product A, 6 million naira profit on product B, and no profit on product C. However, if there is a recession, 10 million naira loss will be incurred on product A, 12 million naira profit on product B, and product C will earn 26 million naira profit. Required. As a business advisor, which alternative should the company choose? Int, use Maximax, maximum, minimax, and Laplace criterion.
All right. Thank you, Yusuf. That is a question. Examiner wants you to appraise each alternative and advise which one the company should choose. Of course, examiner was direct by telling you to use Maximax, maximum, minimax, and Laplace. So even looking at the scenario of the question, you should know that this is decision analysis because you are given state of nature. All right. So in any case, to solve this question, the first thing you need to do is to construct a payoff table representing the scenario in a payoff table. Remember, all relevant alternatives, all your decision variables should be represented vertically, while the state of nature should be represented vertically. In this question, there are three states of nature. We have boom, steady, and recession. So that will be represented vertically in your payoff table. Then, of course, we have product A, B, and C. So once you have product A, you have to construct your payoff table, then you can proceed to using each of the evaluation method to evaluate the alternatives. All right. So that's what you need to do. Then at the end of each one, you have to make a decision. You have to advise what the company should do under Maximax, what the company which of the products to accept or to invest in using Maximum, Minimax, and the rest. All right. So solution, like I said, so you are going to the first thing is to construct the payoff table. So first thing first, you go to the question, identify the state of nature. How many states of nature? In this question, there are three states of nature: boom, steady. Alternatives do I have? There are three courses of action, that is product A, B, and C. I will then go back to the question and be picking the numbers one by one, scenario by scenario. In the first paragraph, you are told that the available information shows that the company will earn 8 million naira returns during the booming period on product A. Therefore, I will go from my payoff table. Under boom, for product A is 8 million naira. I've indicated that. I'll move to the next one. Why 2 million naira loss will be incurred on product B and 16 million naira return will be achieved on product C. So 2 million naira loss on B, 16 million on C. So let's go and indicate that 2 million naira loss, then 16 million naira return will be earned on product C. So as far as boom is concerned, I've represented that information. Then I will move to the next paragraph. You are told further that when the economy is steady, 1 million naira profit will be achieved on product A, 6 million on product B, then no profit on product C. So 1 million and 6 million under steady. Look at under steady, you have 1 million for product A, 6 million for product B, 0 for product C. Then the last paragraph, you're now told that, still on that same paragraph, you're now told that, however, if there is recession, 10 million naira loss will be incurred on product A, 12 million naira profit on B, and then product C will earn 26 million naira profit. So 12 loss, 10 million naira loss, 12 million profit, then 26 profit as well. So that's what you are seeing here. Minus 10,000 is 10 million, okay, 12 million, then 26 million profit. So this is the payoff table. This is the payoff table. Now that I have the payoff table, I need to evaluate each alternative critically using the available evaluation method. So the first one is Maximas. So under the Maximas criterion, so you are expected to select the highest figure in each of the highest payoff value in each row, okay, using Maximas. So all you need to do is to create additional, you repeat the payoff table under Maximas, then you now indicate you now write on the right side, on the right-hand side, you write Maximas. So just like I've done here, okay, that's the Maximas there. So you'll be picking your number from the, you repeat the same payoff table, okay? All what you have here is still the same thing as the original payoff table. So from the original payoff table, you select the maximum number in each row. We have 8,000 for alternative A. We have 8,000, okay? You have 1,000, then you also have minus 10,000. 8,000 is the highest. That's why we selected 8,000. Under alternative B, okay, let me clean this. So under alternative B, we have minus 2,000 for boom, 6,000 for steady, 12,000 for recession. 12,000 is the highest. That's why we selected 12,000. Okay, then under alternative C, we have 6,000, 0, and 26,000. 26,000 is the highest. That's why we selected 26,000. So the rule says, first thing first, select highest value in each row, then select the maximum of the highest value. And that's why, to make a decision, we then say the company should invest in alternative C, in product C. The company should invest in product C to maximize profit of 26 million. That's it. That's what you need to do under Maximax criterion. Then the next one is maximum criteria. Maximum is the same thing as maximi. So under maximi, the decision maker expects the worst to occur. Therefore, you select the minimum value in each row. From the payoff table, you select the minimum value in each row, then you now select the maximum of the minimum value. That's all. So this still represents, all these ones are the original payoff. So all I need to do is to introduce additional column for the maximum or maximum. So for the first alternative A, 8,000, 10,000, minus 10,000. Minus 10,000 is the lowest value. That's why I selected the minus 10,000 being the lowest. Okay. Then in the second alternative, minus 2,000, 6,000, then 12,000. Minus 2,000 is the lowest. That's why I selected that. In the alternative C, 16,000, 0, then 26,000. 0 is the lowest. That's why I selected 0. Then the rule says select the maximum of the minimum. Whenever you have 0, just ignore that 0. You ignore the 0. That's why, 0 is more than minus 2,000. 0 is more than minus 2,000. But because of the rules that state, whenever you have 0, then just ignore the 0. And that's why we pick only the 2,000, 2 million naira loss. Therefore, product B, the company should invest in product B to minimize the loss of 2,000 naira, sorry, 2 million naira. The next one is Savage Regret, Minimax. Okay, the next one is Minimax. Under Minimax, there are 4 procedures you are supposed to carry out. The first procedure is to identify the highest value in each column. Okay, you identify the highest P of value in each column and deduct the highest value from itself and other figures in the column. Then step 2, you construct a new regret table. You construct a regret table. Then step 3, you select the minimum of each row. Select the minimum of each row. Sorry, select the maximum of each row. Then you select the minimum of the maximum value that you have selected. That's what you need to do. So looking at the original payoff table, from the original payoff table for the first column, in this payoff table, okay, under boom, the highest figure there is 16,000. Therefore, 16,000 minus 8,000 will give us 8,000. 16,000 minus 2,000 minus 2,000 will give us 18,000. 16,000 minus 16,000 will give us 0. So that's what we are going to do for all the state of nature. And that's what we have done here. So 16,000 minus 8,000 is 8,000. 16,000 minus 2,000 is 18,000. 16,000 minus 16,000 is 0. So I will go to understudy. The highest figure understudy is 6,000. Therefore, 6,000 minus 1,000 will give us 5,000. 6,000 minus 6,000 will give us 0. 6,000 minus 0 will give us 6,000. Under recession, the highest figure under recession is 26 million. So 26 million minus 10 million will give us minus 10 million will give us 36 million. 26 million minus 12,000 minus 12 million will give us 14 million. 26 million minus 26 million will give us 0. That's step 1. Then step 2 now, you construct a new payoff table, which is the regret table. Okay? So this is the regret table. All the information, all the results you have in step 1, you now put it in the regret table. Then you extend the table by additional column where you are going to indicate the minimax. Okay? The minimax. So under the minimax, you have to start from the right. So first thing first, you select the highest number in each of the rows. So the highest for alternative A, between 8,000, 5,000, and 36,000. So 36,000 is the highest figure. That's why we selected 36,000. In the second row, which is alternative B, between 18,000 and 14,000. 18,000 is the highest. That's why you have that 18,000. In alternative C, it's only 6,000 that is the highest there. That's it. Then you now select the minimum of the maximum value, which is 6,000. Okay? Therefore, the company should invest in product C to minimize the opportunity loss of 6 million naira. So that's what you need to do. You can see it's pretty straightforward. Just understand what you need to do in each of the decision criteria. Yes, the last one is Laplace criterion, Laplace rule. Under Laplace rule, you are supposed to assign probability of 1 over n to each possible outcome. All right, to each possible outcome. So the n is the state of nature. Therefore, the probability that you are going to assign will depend on the number of states of nature. In this question, we have 3 states of nature: boom, steady, and then recession. Therefore, 1 over 3, we are going to assign to each payoff values. So from the original payoff table, okay, for alternative A, so you are going to say 8,000 multiplied by 1 over 3 plus 1,000 multiplied by 1 over 3 plus minus 10,000 multiplied by 1 over 3. That's how you are going to do for all of them. Then at the end of the day, anyone that has the highest expected value will be selected. So that's what we have done here. This is the original payoff table. This is the original payoff table. So starting from the first one, which is 8,000. Therefore, 8,000 multiplied by 1 over 3 plus, open a bracket, 1,000 multiplied by 1 over 3. Then another bracket, 10,000 minus 10,000 multiplied by 1 over 3. So at the end of the day, we have minus 333 naira. Okay, you do the same thing for alternative B. For alternative B, the first item under boom is minus 2,000. So minus 2,000 multiplied by 1 over n plus 6,000 multiplied by 1 over n, 1 over 3. Then plus 12,000 multiplied by 1 over 3. That's what produced 5,333 naira. Then the last one, 16,000 multiplied by 1 over 3. Okay, 0 multiplied by 1 over 3. Then 26,000 multiplied by 1 over 3. And we had 14,000. So we have minus 333. We have 5,333. Then we have 14,000. 14,000 is the highest expected value. Therefore, Product C should be produced. The company should produce product C, considering the highest expected value of 14 million naira. So this is what you need to do. This is what you need to do as far as as far as the Laplace Bayes theorem is concerned. So that's that. So far, we have talked about the maximas, maximi, minimax, and Laplace. So finally, let's have the illustration on the question that was tested in May 2023, question number 1B. We have solved the A part of the question under working capital, where you have to calculate cost of goods sold, then determine the working capital cycle. So we did that question, 15 marks. So the additional 15 marks is this one. So in that May 2023 diet. So yes, let's quickly have a look at the question and then we close the class. Somebody should read, please. Who will help us
Okay.
to read?
I'm reading, sir.
Thank you, Yusuf.
Recently, Panorama Limited decided to open a small new Apple shop in Owerri to be managed by a shopkeeper. The shopkeeper is deciding on the number of boxes of special apples it hopes to buy each day. A box of apples earns a contribution of 400 naira and costs 250 naira. Demand of apple is uncertain and could vary from 30 boxes to 10 boxes. Any apple that is purchased but not sold will be thrown away at the end of the day. The shopkeeper has decided that he will buy 10 boxes, 20 boxes, or 30 boxes each day, and these are the only three options he wants to consider. Required, construct the payoff table for this business in Owerri. How many boxes should the shopkeeper purchase if the decision is on the first one, Maximax decision rule, Maximin decision rule, and Minimax immediate decision rule? Give reasons for your decisions.
Thank you, Yusuf. Now, that is the question. This particular question was taken from Icon Study Pack. When we look at Icon Study Pack, you see it there. However, this is slightly different from the first question we solved under Zebrato. So when you are given this kind of a scenario, I think this is the second time or even the third time that Icon will test this kind of a scenario. However, that's why you have to understand the concept of the payoff matrix, okay? The concept of the payoff matrix table and how to construct it. In this particular question, you are told that the storekeeper wants to decide whether to buy 10 boxes of apple, 20 boxes of apple, or 30 boxes of apple. So your decision is to buy. Therefore, your decision rule, the alternative the alternative courses of action available is to buy 10, 20, or 30 boxes. So that will be represented horizontally. The state of nature is where you have the demand. You are now told that the shopkeeper has decided that he will buy, okay, and these are only options available. We have talked about that. So you are now told that the storekeeper is deciding on whether the boxes of special apples it hopes to buy is a box of apple earn a contribution of 400 naira and cost 250 naira. Demand of apple, that's what I'm looking for. Demand of apple is uncertain and could vary from 30 boxes to 10 boxes. So your state of nature is as per demand of apple. What customer will demand for the apple? So that's your state of now. We are told that it's uncertain. So it could vary from 30 to 10. Therefore, so you are going to have similar thing for your horizontal and your vertical axis, which is 10 boxes, 20 boxes, and then 30 boxes. So what made this question to be unique is the fact that The payoff value is not given. So you are the one that will determine the payoff value yourself using the contribution as well as the cost. So what are you supposed to do? Let's dive in down to quickly solve it within the next 20 minutes. Now, the first thing you need to do, whether examiner asks you or not, you must construct the payoff table. So how do you construct the payoff table? Let's go down there. Now, before you arrive at this payoff table, you must first of all go and work out how to get the numbers. You can see all this 1,500 minus 1,000 were not given in the question. So you must work it out yourself. Now, when you look at the decision that is to be made to make, let me make it easy for you. We have for the under the alternative courses of actions available, we have 10 boxes to buy, 20 boxes. The company can buy 20 boxes of apple. The company can also buy 30 boxes of apple. So you want to know whether you should buy, the storekeeper should buy 10, 20, or 30 boxes of apple. Then we also have state of nature. So under the state of nature, which is demanded for, this is demand. This is what the customer will demand for. Again, you are told that the customer demand is uncertain, but can vary between 30 boxes to 10 boxes. So in this case, under the state of nature, we have 10 boxes as well. 10 boxes, 20 boxes, then 30 boxes. So you want to plot. Okay, this is the state of, this is the payoff table. So you now want to know which one you want to buy. Is it to buy 10 apple or to buy 20 or 30? Okay. Yeah. So what you are supposed to do, remember, profits is equal to contribution minus cost. When you less cost from contribution, you are going to get profit. So it is that profit you are going to put in each cell. You can see now there are possible states of need. There are possible 9 possible outcomes. Outcome 1, 2, 3, 4, 5, 6, 7, 8, and 9. There are 9 possible outcomes that may occur. So if that is the case, how do you determine the payoff value, the profit for each cell? So what you are supposed to do is that you are going to start from the contribution, because you can't start from the cost. You are going to start from the contribution. So to get the profit you are going to put in this first cell, what are you supposed to do? Then you are going to pick. Remember, according to the question, contribution is 400 naira per apple. Therefore, what you are supposed to do is to multiply the first column. You multiply the first column with all the 3 rows. That's the first option. Multiply the first column, that is 10 boxes. Multiply these 10 boxes where you have the demand, these 10 boxes where you have the demand, multiply with the entire rows. Multiply with the first 10 boxes, 20 boxes, and 30 boxes for each alternative. So that is what I've done down here. Let me look for a better space, a bigger space. Not too far. This is too far away. I just want you to understand it so that it won't look as if I'm picking the solved. Okay, now this is what we are trying to say. The first option, the first action that you are going to take is to multiply the first row. Multiply the first row Okay, multiply the first row, sorry, first column, because that's where you have the contribution. Multiply the first column with all the rows. That's the first action that you are going to perform. Therefore, in the first row, for row 1, under row 1, you have contribution is 400 naira multiplied by, in this row 1, in the first column, remember we said multiply the first column with all the rows. So I want to multiply, let me change the color to red. Now I want to multiply these 10 boxes with all the rows, all the 10 boxes, 20 boxes. I want to multiply with all of this. Okay, I will multiply the first row, the first column with all the boxes. Therefore, let's go and do it. I would then say 400, let me return. So I would say 400 multiplied by 10 apple, that is contribution, that's total contribution, that the first one, minus then 10 boxes, which is 250 naira is the cost, multiplied by 10 boxes. Okay. I will get the answer. In row 2, it will be equal to 400 multiplied by, we are still multiplied by 10. Customers are demanding for 10 boxes. How many boxes do you have? You have 20 boxes. So multiply 250 multiplied by 20. You get the answer there. The third row equal to 400 multiplied by 10. You can see in the column, I did not talk about the 20 boxes under the state of nature. I didn't talk about 20 boxes and 30 boxes. I focus on the 10 first because you have to multiply the first column with all the rows, and that's what we are doing. Therefore, minus 250 multiplied by 30 boxes. So I will get the answer. The first one, 400 multiplied by 10, that's 4,000.
The first one is 15.
So that's 1,500. Then the second one, 4,000 multiplied by 5,000. That should give us minus 1,000. Okay, that's minus 1,000. The
Yes.
third one is 4,000 minus 75. That should give us minus 3,500. So I've gotten the payoff table for the first column. So I will then come here. Let me change the color to red. So I will then say 15 minus 1,000, then minus 3,500. I will repeat the procedure again. This time around, I'm going to the second column because I'm done. I'm done with the first column. I'm done with this. I'm going to the second column now. So I will now multiply the second column, which is 20 boxes. I will multiply with all the rows. Okay? Because of space, I will clean this one. I will do it again. So this will be option 2 now. Let me change the color. Change the color to, let me use this. Okay. Okay, that's the second option. Multiply the second column. In this case, it will be the second column with all the rows. So for the second column, under the second column, customers are demanding for 20 boxes of apple. Customers are demanding for 20 boxes of apple. Therefore, in the first column, you don't have 20 boxes of apple. The company has only 10. In this place, the company has only 10. You don't have up to 20. Therefore, you have to restrict to what you have. Customers are demanding from 20 apples, but you have only 10 apples. So you have to restrict to what you have. Therefore, 400 multiplied by 10, because we are selling 10. 10 is what the customer will sell. So you cannot sell 20. So that's why you are seeing this one is remain as 10. Then multiply by the 20, 250 multiplied by 10 is still the same 15. Then I'll move to the second row. For the second row, in this case, I have 20 apples. Okay, I will then say 20, this one will be multiplied by 20. All right, then 250 multiplied by 20 will still remain. Then I need to get the value there. Therefore, 400 multiplied by 20 is 8,000. 250 multiplied by 20
That one
is
is
5.
3,000.
That's 3,000. So this one will be 3,000. Then I'll move to the third one. So we are still multiplying the second column with all the rows. So 20, customer are demanding for 20, but you've already bought 30. Therefore, of course, this one will still remain 20. Your contribution will remain 20 because that's what you want to sell to the customer. You can't sell more than what you have to the customer. So that will be 8,000 minus 75. That's minus 500. Sorry, that's 500. Okay. So I will then go and post 3,500. 3,000. Then 500. Because this is the most difficult part. Once you get your payoff value correctly, every other one is straightforward. Then the last one, let me change the color again to green. Now, don't let me use green. It's close to the, let me use this. Let me use black. Let's use black. So in the last one, no, change it to this. So in the last one, customers are demanding for 30 boxes. That is the column. So you are going to multiply the third column with all the rows. So I will then come here, I will change it to option 3. Okay, so multiply the third column with all the rows. So in this case, for the first row, customers are demanding for 30 boxes in the first column. Customers are demanding for 30 boxes, but you have just 10 boxes available. So you have to restrict it to 10. So how much is the cost of that 10? 250 multiplied by 10 will still give us 1,500. The next one, customers are demanding for 30. In the second row, you have 20 boxes. So 400 multiplied by 20 minus 250 multiplied by 20. So 8,000 minus 5,000 will give us 3,000. Then the third row, you multiply 30,000 boxes in the column, you multiply with the 30,000 boxes of apple. So here will be 30. This one you change to 30 because you have the 30. Therefore, then of course you are buying 30 at 250. So 12,000 minus 8,000 will give us minus 75 because 250 multiplied by 30 is 75. So 12,000, that's the 4,500. So that's, this one will then be 3,000, then 4,500. So that's all you are going to do to get your payoff table. All this one I have written here is oversimplification. I've oversimplified it for you. That's why you have all of this there. So you go through it, it's the same thing that we have gotten so far. It's the same thing. Just explaining more details in this material. So you can see that the boxes demanded must match the boxes available. That's what we have done. So we are restricting it to what you have available. So this is the payoff table that we have drawn here. That's the payoff table. At this point now, you can solve for the other ones using Maximin, whatever is very straightforward. So using Maxima's criterion, you are supposed to select the highest payoff value in each row. So that's, we select that 1.5. Let me change the color to something else, blue. Okay, we select the highest value. In the second row, minus 1,000, 3,000, 3,000. 3,000 is the highest. Minus 3,500, 500, 4,500. 4,500 is the highest. Therefore, we select 4,500. Then the company should purchase 30 boxes to maximize profit of 4,500. That's what you need to do. Then under the maximum criterion, so we are selecting the minimum value in each row first. Minimum value 1.5 is all we have all through. So that's the 1.5. The second row, minus 1,000, 3,000, 3,000. Minus 1,000 is the lowest. The third row, minus 3,500, 500, then 4,500. Minus 3,500 is the lowest. Okay, then you now select the maximum of the lowest of the minimum. That's why we selected 1,500. Therefore, the company should purchase 10 boxes of apple to maximize profit of 1,500. Okay, that's it. Then the third one, we have to use minimax regress criterion. To do this, from the original payoff table, in the first column, we go back to the payoff table. In this column, the highest figure is 1,500. In the second column, highest figure is 3,000. In the third column, highest figure is 4,500. Therefore, in the first column, 1,500 minus 1,500 is 0. 1,500 minus 1,000, that's 2,500. 1,500 minus 3,500, that's 5,000. So you keep the answer there. In the second one, 3,000 is the highest. Therefore, 3,000 minus 1,500, 1,500. 3,000 minus 3,000, 0. 3,000 minus 500, 2,500. We go to the third column. Highest value is 4,500. 4,500 minus 1,500, that will be at 3,000. 4,500 minus 3,000, 1,500. 4,500 minus 1,500, that will give us a 0. So you now construct a new payoff table, which is the savage regret table. Okay, you construct a savage regret table. So in that savage regret table, all the answers you have in this first one, in the first step, so you put it in the payoff, in the regret payoff table. So the next thing you need to do now is to select the maximum value in each row. From this regret table, the maximum value is 3,500. Sorry, it's 3,000. Okay, that's why you select the 3,000 here. In the second row, the highest value is 2,005. That's why you see the 2,005. The third row, the highest is 5,000. That's why you see the 5,000. Then you now select the minimum of the maximum. Then the minimum of the maximum is 2,500. Therefore, the company should purchase 20 boxes to minimize the opportunity loss of 2,500. That's all. That's the end of the question. Right on time. That's the end of the question. Just take your time, understudy the concepts, understudy the question and answers that you have. There are other illustrations that you can practice on your own. This one was tested in 2014. Okay, this illustration number 3 was tested in 2014, which is similar to this illustration we just solved now. Okay, it's similar to that one. So go through it and have the deeper understanding, because you don't know where examiner will come out to you. All right, this is another illustration number 4. I think I have about 5 different illustrations here. So yeah, go through it. In this particular one, yeah, examiner was there is a particular question where examiner is asking is just purely theoretical. You are just asked to explain, okay, to explain all those concepts. Let me see. I think, yes, this illustration number, I think this is the illustration number 5. It was tested in 2021 November, and then students were asked to explain. Yeah, you're asked to, in the requirements, you are told that no calculations are required. Explain 4 methods that could help Mr. Johnson to decide which marketing package to choose. Your answer should include 3 methods to deal with uncertainty. one method to deal with risk. So to deal with uncertainty, you can use Maximax, Maximi, Laplace, Minimax, and all of that. Then one method to deal with risk, you can use expected value, you can use standard deviation, you can use sensitivity analysis, and then an explanation of the attitude. So that's what I was telling you the other time, that the maximums is mostly preferred by an optimistic individual who expects the highest to occur, who expect the best to occur. All right. So this is what examiner is asking you. Just go through them and have a deeper understanding of the concept. That's it. That's it from me to you. All right. So for the risk, you can use any of these ones to measure risk. All right. So that's end of risk and uncertainty. That's end of risk and uncertainty. All right. So these are the attitude of the risk of the individual investor. For a risk taker, a risk averse, and then a risk neutral individual investor. So yeah, that's it. Okay, guys. Let me know if you have any question for me so that we can close the class, and we'll meet again next time by the grace of God, when we shall be starting a new topic, which is the capital budgeting. Yeah. So any question for me? Hammond, I
Yes,
couldn't
sir.
hear. Yes, talk to me, Kunle.
I'm sorry to take you back, sir. The previous question we solved before this, the Laplace, I have a question there.
Okay.
If you can take it to that, please, sir. Sorry, sir.
All right. That's illustration number 1. Okay. Yeah, this one. You mean the Laplace?
Yes,
Okay.
the question before this.
Yeah. Yeah, this is it. This is the Laplace. You have to talk to me.
So I understand the point at which you, for A, 1/3 times 8,000 plus 1/3 times, and not the rest. That gave us 2,667, but I don't understand how we got the 333 and the 3,333.
Yes, now you are just see 8,000 divided by 3 we give you 2,667. 1,000 divided by 3 we give you 333. 10,000 divided by 3 we give you minus that. Then you add it up.
All right. Thank you, sir.
You're welcome. Okay. So in the absence of no further question, this is where we are going to call it a day. I will see you next time by the grace of God, when we shall be starting a new topic, which is capital budgeting. Good night to you all. Bye-bye.
Good night, sir.
Good night.